Hello, everyone. This lesson is to review the concepts that we learned before our break. So we'll be reviewing how to tell if it's a quadratic function from its equation. We'll look at some characteristics of the quadratic function from the graph. And as well as we're going to look at the transformations. So we'll be looking at the different parameters, A, H, and K, and recognizing how they change the position or shape of the parabola from y is equal x squared, as well as we'll be writing our own transformations if we've been given an equation. So let's get started. Our first exercise here is to indicate whether the given function is linear, quadratic, or neither. So we know if it's linear, both the independent and dependent variable will be of degree 1. And if it's quadratic, we know that the independent variable will have a degree 2, and the dependent variable will be of degree 1. And if we have neither of these cases, then it will be, we'll write in neither. So let's look at our first example. So x is the independent variable, and it has a degree of 2. Y is a dependent variable. It has a degree of 1. So if y is a degree 1 and x is degree 2, this is a quadratic. B, the y variable or the dependent variable is a degree of 1, and the independent variable or the x is degree of 1. Therefore, this would be linear. C, x is degree 2 and y is a degree of 1, so this would be quadratic. If we had neither the linear or the quadratic case, then we would have just written neither for those examples. The next thing we want to review is how do we identify different characteristics of the parabola from the graph here that is shown on the page. So let's start off with the vertex. Remember, the vertex is where the graph changes from going from increasing to decreasing, or if this were a minimum, from decreasing to increasing. So this is the vertex, and the vertex is a point. So we're just going to write down the coordinates of that point of -1 and 4. So the vertex is -1, 4. The domain and range. We've studied this a bit before. Remember, the domain is all the x values that satisfy our function. In this case, where we have arrows, that means that this function will continue on, or the graph continues on, and there's no real restrictions along our x values. Negative, zeros, positive would all be part of our set. So we know that x is a member of the all real number set. The range, though, we can see the graph here comes up to this maximum value here. There are no y values above 4, where our max value is. So we know our range is all the values that are less than 4. So the range is y is less than or equal to 4, and y is a member of the all real numbers set. From looking at the graph, this is looking down. Remember, if it's a sad face, it's down. If it's this way, a smiley, it's up. So we have a graph that is downward facing. The equation of the axis of symmetry, remember, symmetry is where we divide our shape, or in this case, the parabola, into 2 equal parts. So this is our line of symmetry, and we look for the x value there. So since it's a vertical line, it's written in the form x is equal, and in this case, -1. So our symmetry is x is equal to -1. The x-intercepts, remember, that is where the graph, in this case, a parabola, crosses the x-axis. And so here and here, at -3 and 1, these are x-intercepts. So our x-intercepts are -3 and 0 and 1 and 0. Y-intercepts. So the y-intercepts are where we cross the y-axis. And as we can see, the graph is intersecting here at the y-axis. So this is our y-intercept. And our x value there is 0, and our y value is 3. So that is the y-intercept. And I've already stated that this has a maximum value because we notice it goes up to a maximum value here of 4 before the parabola starts decreasing again. So we do have a max value, and it is equal to 4. So that's just a review of some of the characteristics that we've learned. So let's move on to the language of transformations. Remember, we are transforming graphs from the parent equation or base equation of y is equal x squared. So how does the graph move around the axes or change shape in relation to the parent function of y is equal x squared? So once again, if we have the negative in front of our equation here, or the a looks like it's negative, then that means it opens downward. And we call that a reflection in the x-axis. The a value, if a is greater than 1, then we know we have a vertical stretch by a factor of a. If a is between 0 and 1, we have a vertical compression by a factor of a. H. Our H value, remember H horizontal. H is a horizontal translation. H units left or right. Remember, horizontal goes from left to right. The K value. The K value is our vertical translation. K units up or down. So to summarize, the A value here will change the shape of our graph. So it will make the graph either thinner or maybe a little bit wider. And the H value will move the graph up and down. The H value will move it left and right. And our K value moves the graph up and down the axes or on the coordinate grid. So we're going to use those transformations, and we're just going to write transformations from the actual equation. So our example is describe the transformations applied to the parent function. Remember, we're always doing transformations from our parent function, x squared, to obtain the following quadratic equations. So once again, we're just going to be using this equation and writing them down in that order. So first off, if there's a negative, that would mean we have a reflection here. We do not have a reflection. That means the graph is opening upward, just like x squared would open upward. Therefore, there's no transformation for us to write there. Also, our a value here is equal to 1. As you notice here, if a is greater than 1, we have a stretch. If a is between 0 and 1, it's a compression. There's nothing here for a equals to 1 because if a equals to 1, it stays the same shape. It doesn't get wider, it doesn't get thinner, so we don't need to write a transformation. Then we have our h value, which is 6. We said the h value is a horizontal translation, 6 units. And this, because it's a positive h value, 6 units right. We also have a k value, and our k value is equal to 4. We know the k value is a vertical translation, 4 units. Since it is a positive 4, it'd be 4 units up. So let's look at example B. So just starting, remember, you're just going from left to right. Most things we do, whether we're reading or not, we go from left to right across the page. Our very first thing we notice here is we have a negative. So we know the negative is a reflection in the x-axis. Then we move along and we see we have the 4. So we know 4 is greater than 1, so we know it's a vertical stretch by a factor of 4. H is equal -5 here. So we have a horizontal translation, 5 units left. And lastly, we have our 8 right here, which is K. K is equal -8. So we have a vertical translation, 8 units. Since it's negative, this will move the parabola down. So that's a little summary of some concepts we did before the break. So if you are having some problems with some of these concepts, you could go back and complete some extra practice on page 48 in your textbook. Remember the textbook, there is a link on Brightspace for you to access the textbook. So just go on there and it's page 48, 3, 5 to 7, and on page 56, 3, 4, 5, A, and C.